Recording.
Too loud. I turn off.
你在这讲就行。
And Xiaobo Huang is graduated from Harbin and Industrial and Technology, and he also get a BS and he also get a master and a PhD from Minnesota University. And after that, he worked for Tower Semiconductor and also West Digital for several years. He concentrated on the deposition for physical and film, thin film. Now today he will bring a topic for us, and is the application for the medical use for the thin film deposition. Let's have Xiaobo on the board. Thank you.
Yeah, let me share. Yeah. Yeah, hello everyone. Yeah, it's a good time to meet for everyone, but because I have an airplane soon, so I cannot go on site. Yeah, sorry about that. So this is actually the teamwork and the proposal. The topic is application of diamond-like carbon fuel in a medical device. Diamond-like carbon, we call it the DLC. So hold on, please. The background is so we have for the tooth implant, we have some problem. The main problem is a long treatment cycle, and it will take a few months to fix the implant body to the jawbone. It makes a lot of painful for the patient. And the second one is incorrect bite load and infection, failure and treat inflammation and allergy to the patient also. During that 6 months, people cannot eat well and lost weight and a lot of good life. And then another thing is easy to fall off. And the second application is the artificial joint problem. So over the 15 years, so people maybe need to replace the joint again. So, but after 15 years, people getting older, which make more trouble to the people. And meanwhile, it takes a long time to combine the joint to the human body, same as the tooth, make a lot of painful and the time for the people to recover. Another thing is the last thing is the structure size changed during the movement and causing some particle or things make the drawing not uncomfortable to the patient. So we'll propose some solution. We can use the DLC, the diamond-like carbon, to cover the tooth and the drawing to solve this problem. Because I will show later. Next one. So why we use propose to use a diamond-like carbon? And diamond-like carbon is the structure of the diamond, which has a face sp3 and the sp2. sp3 is like a diamond, so it's very hard, and sp2 is like a carbon, so it like little soft. So it combines these two mechanical properties together. So it gives us the film smoothness and the oscillation good, and the super hardness and the corrosion resistant and the good wear resistant. Because the carbon, the diamond-like carbons, it has good anti-oxygen, water, UV how to anti-oxygen functions, and since the carbon is combined to our body easily, so the right side is the current application of DLC fuel. For example, for some mechanical parts and the pumps. And since I worked in the hard drive company for a while, so DLC is used in the hard drive for many components to improve the hardness and lifetime of the magnetic heads. All the head covered by the DLC film. And like some window, we covered by DLC to improve the hardness and IR reflector and the blade and some draw and watch to cover this film to improve the properties of the surface. And the main part is the mechanical device and some bottom we use to improve the anti-oxygen properties. So our project is to combine this excellent property of DLC, particularly the wear resistant and human affinity, to apply the DLC coating to the human drawing and dentistry. And use why we use how can we generate this film? We use the high power pulsed magnetic sputtering system to develop this DLC film. So by using this tool, we can deposit a DLC film on the artificial drawing and the tools. And this film, like I mentioned, because it has a very good property, so it can improve the welding resistance of the artificial device and prolong the service time. And it has a broad application in the market, in the biomedical area. So how can we generate the DLC film? It uses, like I just mentioned, it uses the magnetic sputtering system or the PVD, but we propose to use the magnetic sputtering system. So the plot in the middle shows here. So the plasma generated between the anode and the cathode, then deposit the film to the substrate. So the target has a magnetic on the backside. So it can subtract the plasma in this area to improve the efficiency of the deposition. So by using this tool, it has a short time for the to form the high density plasma and the high density of ionization. And it has a high energy of the sputter particles to improve the efficiency. And this system has a very low temperature, so it can be used to coat some substrate which cannot be used under the high temperature. And it has a very good bonding force between the membranes and the substrates to improve because it has the high density plasma and the very dense thin film properties. So the bottom right shows the plasma generated pulse. So actually you can see when we include the DC, so the pulse generated during the circle time. So the plasma can increase how to say deposit the film to the substrate directly. How can we use this for the bio application? First, the patient need to go to doctor to see the doctor to make the mold. Then we use the DLC, use the 3D printer to generate, for example, the tools or drawing, and then use the DLC to coating the surface of the mold. Then send this mold back to the clinical. Then doctor implement this to the patient body. So it has a big market if it can be used for the biomedical device market. So we roughly calculated the market. The domestic market for the artificial drawing is renminbi around 10 billion, and for the global market is around US dollar 50 billion. The domestic market for the dental implant is nearly 500,000, and with the annual growth rate of about 30%, which is roughly renminbi 6 billion. This project needs cooperations and need time to develop the process. We propose that the first year we need to fund the $2 million to purchase the tool and do the process development. Then after the development, we cooperated with the hospital and the dentist. Then use the process. There is the exchange information between these two, between the doctors and us, because based on the application, we need to develop the process. Then use the process to generate the artificial drawing and the dental implement. Then feedback to the hospital and the dentist. Like I mentioned, this is the teamwork in this team. So we have Dr. Zhang and myself, and Asuki-san, and Dr. Chen. That's it all. This is all I have. Any questions for me?
Okay, good idea. Yeah, semiconductor and C-film topology used to medical. Yeah,
good
that's a good idea. Wow. Yeah, focus on the marketing, huh? Yeah.
This is the only proposal, so need a lot of to do.
And anybody have any questions?
So I have a question. So how mature for this technology, especially for the dental?
The DLC film is mature, but the dental, we need some process development. Because current DLC already broadly used for many areas.
Okay.
So
it means
go ahead.
So it means applying for the dental is easier.
It's easy, very easy. Yes.
Okay.
Really?
Good. So currently only have the revenue in the Chinese market only 500K, but there will be 30% increase, annual increase, right?
That's right. We predict, yeah.
You predict. So do you have any pilot testing in Chinese dental industry?
Right now, no, not yet.
Not yet. But how you calculate the 500K?
Because the current tools implement market.
Oh, it was implement market. Implement market.
Yeah, I think market should be here. Yeah, market I think is there. How you catch that?
Yes.
Yeah. My question is, and
another thing is need FDA, all the things, do you know? Regulation, this is important part of.
I have a question, and for the dental, for the teeth, how thick you deposit the thin film? How thick you need to develop?
How thick?
Oh, this film is we can control it from angstrom to micron level.
Really?
Yes.
Yeah, that's difficult because, and also my another question is how big is your chamber? Because tooth and you, how many tooths you put together and to deposit? That's you see the production
The chamber is need actually how to say the chamber. The chamber depends how how big the fund is.
Oh, I mean how efficient. Because you just put one person's tooth inside, that's and how much you cost. Yeah.
Oh, that is not a problem because based on my experience, so actually, it's called whole chamber actually. You depends on how much. For example, for the hard drive company, right, we use a 8-inch wafer, 6-inch wafer. So by using same recipe, we can coding both. But if we can increase the chamber size, I think we just increase the gas amount, dose. So it's not big problem.
Okay.
You see, it can cover to the all these applications. So I don't think it's a big problem to cover to reduce the cost for the tools implant.
You did any like and the proto test use some and existing and machine to deposit the tooth?
Not yet.
Yeah. Maybe yeah, do that first to be better. Yeah, you can show the result. Yeah.
That's right.
So I don't have any knowledge about the material. Just wondering if you can use it for implant, you can use for the teeth, you can use it for the other body portion, right?
That's right. Yeah, because DRC film is like I just mentioned here. So it's a diamond and a carbon combination. So it in carbon is so hard and not so a diamond is so hard, but a carbon is soft. So
So SP3, SP2 stands for the hardness level.
no, it's a face. It's like a diamond piece, but diamond shape or the graphene shape.
Oh, I see, I see.
If we in future develop some and the new technology, you can deposit it in the thin film directly in your mouth. That'd be great, You don't need use a toothspray. Yeah, that'd be great,
No, actually, that is a good idea. Actually,
Yeah.
people use the hand the handle machine, right? So you see, for the dentist to code
Yeah.
code DRC on the tools directly.
I think and the number, I'm not sure number one and the number two, you can cure cancer, you can cure some other disease, but for teeth, you still need to go to the dentist, Yeah, that's the problem. Yeah. Any other questions? Yeah.
You want to DIY?
I really want to DIY. Yeah, you can borrow to my tooth. Oh, great. Oh,
Any question
Yeah.
from the online?
because and I am a equipment engineer before. I'm a CMP. I'm not technology. Yeah, I said that, but I'm very familiar with this technology. Yeah, if this technology can be used for a human being, that'd be great. Yeah.
So, for the audience, yeah, this is a good time for you to talk to Dr. Fang. Is there any questions? So one question from me. So
Sure.
Dr. Fang, you have a team, and I think you introduced 4 people. Then, what is the role for each person?
Oh,
Team members?
the team member, yeah, Dr. Zhang is in China right now. Me and Sugi-san in America, and Dr. Chen is in China or Japan. I'm not sure yet.
So what is the each person's role as a team?
Oh, actually, Dr. Zhang is the lead. Yeah. So
Hmm.
me, Osugi, and Professor Zhang, that's a process development and application.
So I don't know exactly, but the first target will be for the dental market. Oh,
Dental.
dental market. That is a
Artificial.
that's the
Yes.
first target.
Yeah, so that's why we need the dental clinical doing cooperation. So
Hmm. So what is the rough timeline for this project?
timeline.
Just say, let's say you said first year.
So the first step, we need to get a funding. Actually.
Yeah, I understand.
This is not our full-time job. Just interesting project to do for everyone.
And development, application, and cooperation.
Yes.
Maybe
Because four of us, so we have a lot of experience on the equipment side and process side. We just analyze this idea and do some research and literature review to generate this idea. So we think it should have a broader application in the biomedical device market.
Yeah, reason why I'm asking you is that once it's finish the one cycle of your project plan, I'm just wondering if we can explain the results and your project too.
That will
in the
be great.
future.
Yes.
Okay. Yeah, it's a really good presentation. Any other questions?
Is this a patent idea by you? Or it's the well-known, it's an idea itself is not new, just no one developed it. What's the,
Pardon?
is the idea, is you, do you have the patent on this idea?
Yeah. Dr. Zhang actually, he is not available. He should give this talk, I think. Yeah, he has patent. Yeah.
Mm.
Protect.
So this idea itself is brand new. So in this world currently, no one else is working on this idea.
Yes, it has a lot of application on other area. For the biomedical device area, I think it's new. Yes, particularly for the tools application.
I see. Thanks.
So any other question?
What I can see is good job.
You were going to fund it.
Huh?
You will fund this project.
Yeah, I can find $5.
Our team is trying. Keep trying this to
Where are you located?
here and China both.
Silicon Valley and China.
Okay.
Both are.
I can fund your next week's launch 5 times.
So yeah, thank you so much. It's a pretty much interesting topics. Dr. Fang, thank you so much. It's a really good presentation. So
So sorry, one more thing. So I have to leave because I have an airplane soon. So
Thank you
for
very
that.
much for your effort. Yeah.
yeah, thank you so much. Thank you very much.
No problem. Bye.
So thank you. So this is the time to conclude the seminar. So anyway, if we have any comment or questions, please contact me htomita@noi.ac.com. Then now we will reply back to you as soon as possible. So again, then next today number 11 seminars, and we make a plan. We plan that the next seminar will be next year, probably on March, and we will invite you, all of you, to this seminar, next seminar as well. Okay, thank you so much for joining us today. With the seminar will be done. Thank you so much.
Thank you.
Bye bye.
Bye bye.